What's happening there, YouTube? Genji here, and today we're hopping back into StarRupture, where today we'll hopefully be able to clear off the left-hand side of our Rupture Planner and finally work our way into our higher-end manufacturing. But before we hop into today's build, we have a few things to take care of, starting with the stuff that I did in between episodes in preparation for today's episode. Starting with our cooling towers over here that we needed to offset the insane amount of heat that we were generating from our compounder factory here. So I ended up needing 6 total stacks of base core amplifiers, but if I put the UI back on, we can see that we're finally offsetting our 2400 units of thermal load here so we can wander away from this base for a while, and I don't think we'll really need to touch this until we come back to do some things with synth resin. But for now, we're going to head on over to a couple other factories I built in between episodes. Nothing particularly exciting, but I did have a couple of low-tier items that I need to get set up in dispatchers so that they're available to us for some factories that we'll be making later on. Starting with stators here. So this factory is taking wolfram and titanium, smelting them into bars, then feeding those bars into the manufacture of titanium beams and titanium sheets, which are then becoming titanium housings. Here we have wolfram wire, which is being combined with the titanium housings here into the manufacture of stators, which then go into a dispatcher. And finally, rather than going back to our sulfuric acid factory and trying to rebalance our outputs to fit in an additional 4 dispatchers for acid, I opted to set up an additional pressurizer to make some more sulfuric acid. So this factory is just pulling in calcium and wolfram, refining those into calcium powder and wolfram powder, then combining those with helium-3 and goethite ingots in a furnace V2 to make chemicals. Those chemicals are then being combined with sulfur ore here in the pressurizer to make sulfuric acid at 120 per minute, and then into a storage depot, and then rail balanced into these 4 dispatchers here. Now, because we needed 4 additional dispatchers and our storage depots only have 3 independent outputs, I did have to rail balance 2 of these together using a modulator, and I did that based on the 2 downstream factories that are going to be using the least amount of sulfuric acid. So I went ahead and named these so that I know where they're going to be going. So this dispatcher is going to be sending sulfuric acid to our organic compound factory, which is only going to be using about 5 acid per minute. Next to that, we have sulfuric acid for plastic production, which is going to be using about 18 per minute. Then we have sulfuric acid for pump production. Pumps are going to be using about 36 sulfuric acid per minute. And finally, we have sulfuric acid for batteries, which is going to be using 45 acid per minute. So all of these fit inside of our 120 per minute that we're manufacturing here in this extra pressurizer. So we should be fully good now on our sulfuric acid. And finally, before we hop into today's build, I wanted to do a little rail science in order to answer a question that was left on my last video. And that question was essentially why I always set up independent rails for every item, and I don't ever try to join items together onto a single rail. So I've set up this little example here, and I'll show you what we have going on here, but the TLDR for this question is that you can do that, but you have to be extremely conservative with your calculations for balancing these items together onto a single rail. So to prove that, I have this example here, which is 4 furnace V1s that are all manufacturing chemicals. And we have a series of storage depots that are providing our ingredients. We have synthetic silicon here on its own rail. We have helium-3 and wolfram powder that are being joined onto our second rail. And if we take a look at our calculations for this recipe, we have 1 synthetic silicon, which is not really going to be important here because it has its own rail, but we also need 3 wolfram powder and 1 helium-3, which are going to be sharing a rail. So every 2 seconds, which is 30 cycles per minute, we're going to need 4 items to come across this rail. 4 times 30 is 120. 120 times 4 machines is 480 items per minute, which is the theoretical maximum of a V3 rail. And if you notice, I've already filled our internal buffers here, so there's not going to be any extra demands from filling buffers here. These rails are just going to be providing what these recipes actually need to sustain the manufacturing. So if I put a power plant down here to fire everything up, what we're going to see, if I come down to the end, although it's the same for all of these, is if these rails were truly running at 480 items per minute, all of these machines would be able to replenish themselves infinitely, and these machines would run at 100% efficiency forever. What we're actually going to see is that our wolfram powder is going to slowly deteriorate over time, it's not actually able to top up our wolfram powder fast enough. Technically, it's also not able to top up our helium-3 fast enough, but the draw on the helium-3 is low enough that it's not really as noticeable. We can see that our wolfram powder is already depleted down to 80, now down to the 70s, and this will continue down and down and down until we hit 0 on wolfram powder, and this machine will pause and wait for more materials to come in, so our efficiency will drop. The reason for this is because, again, the rails are not perfectly efficient. And in order to break down the math as to why, I've changed up this scenario into a number of smaller experiments, which I'll show you here. So we're going to pop over to Adobe Premiere, where I have pre-recorded these experiments in between episodes, because I wanted to make sure that all of our mathed out before I try to do this live on camera. So this is our first experiment where we have the same chemical manufacturing setup, but with only one furnace as connected directly to our 3 furnaces here. So I kind of walk through. I'll hit play on this. I kind of walk through here just to show the setup. We're going to set manufacturing for chemicals, and then I'm going to switch this machine off so that we can set up our experiment. And the setup for these experiments is pretty simple. I just want the output buffers of these machines to be full and the input buffers to be empty, because I'm going to be timing how long it takes from the moment that the first item enters the input buffer to the moment that the last item enters the input buffer and fills it up. And to do that, I need the machine to be powered on, but not manufacturing, because I don't want it to actually pull any input items away and then turn them into output items. I just want the input buffers to fill up. So as soon as I hit the power on button here, I have a time code that I've embedded into the video that will start counting up the exact frame that the first item arrives into the furnace, and it will stop the moment the last item arrives. So let's see how long it takes for a directly connected furnace to receive a stack of 100 items. And we're going to pay attention to the helium-3 in this case, so let's go. There we go. So if I scroll back, our total time, the moment that we hit, the exact frame that we hit 100 items in our input buffer, is 14 seconds and 18 frames. Time is a little bit weird in Adobe Premiere, so the last number is not the number of microseconds, it's actually the number of frames. So I have to do a little math to convert that back into actual decimal representation of seconds. Now, I've already done the math in advance, so I'll throw it up here on the screen. But 1 second divided by 30 frames per second gives us a frame time of 0.0333 repeating seconds per frame, times 18 frames gives us a total of 0.5994 seconds, which will add back onto our 14 seconds to give us a total of 14.5994 seconds for our buffer to fill from completely empty to completely full. Now we can figure out how long it takes for each item to enter our machine by taking our total of 14.5994 seconds for our buffer to fill and divide it by 100 for 100 items to get a total of 0.1459 seconds per item. We can take that time and compare it to the expected time that a 480 item per minute rail should run. Now we can get that value by taking 60 seconds, dividing it by 480 to get a total of 0.125 seconds per item if the V3 rails are running at 100% efficiency, or the theoretical rate that they should be running at. Now we can take our observed rate of 0.1459 seconds per item and compare it to our expected rate of 0.125 seconds and see that there is a divergence of roughly 0.02 seconds per item when a machine is connected directly to a storage depot. Now this seems really inconsequential, but if we divide our expected rate of 0.125 seconds by our divergence of 0.02 seconds, we get a surprisingly large number, a 16% time divergence for items to arrive into our machine from the depot. Now we can't reach a conclusion based on a single experiment, so we're going to do this experiment multiple times, and every time I'm going to increase the complexity or change the parameters of the experiment by adding an additional machine to each experiment so we can see if our divergence time scales with the number of machines and complexity of the rail network. So I'm going to load up our second experiment here. Now, this is a similar experiment, except as you can see, we're splitting every ingredient through a rail connector into 2 machines now instead of a single machine. After applying power, I pre-run both machines in order to fill up the output buffer and then remove all of the inputs. At which point I will reapply power so that both machines begin operating at the same time and start pulling in items from the depots at the exact same moment. And now we'll run up a timer to see how long it takes for the internal buffer for helium-3 to fill up. So we'll speed this along until we hit our full internal buffer, and then I'll scroll back here until we can see the timestamp reappear. And there's our final value of 29 seconds and 12 frames to fill up the internal buffer on a machine where the rail inputs are being split between two machines with a rail connector. So if we do our frame math again, we have 12 frames at 0.033 seconds, gives us a total of 0.3996 seconds. Add that to our 29 full seconds, and we get a total fill time of 29.3996 seconds. So in order to calculate our divergence from our expected rail speed, we take our total of 29.3996 seconds, divide it by 100 items to get a per item time of 0.2939 seconds. Now in this example, to derive our expected rail time, we're going to divide 60 seconds by 240 because the rail connector is actually splitting our throughput between two machines. So each machine is getting 50% of the rail capacity. So instead of dividing by 480 items, we're dividing by 240 items. So 60 seconds divided by 240 gives us an expected per item time of 0.25 seconds per item. Now we'll compare that to our observed time of 0.2939 seconds per item, and we get a divergence of 0.04 seconds per item. So in our single machine example, we had a divergence of 0.02. With two machines now, we have a divergence of 0.04. So our divergence seems to be scaling with the number of machines, or essentially the number of exit points from this rail network. So to recalculate the percentage of our total divergence, we take 0.04 divided by 0.25, and we get a total of 16% divergence again, which is the same that we got for our first example. Now we'll run this experiment one more time, adding a third furnace so that each ingredient goes to a rail connector that is split between 3 factories each. Again, I pre-run all the factories to fill up the output buffers and then cut power in order to remove all the input buffers, then reapply power again so all of the input buffers of the machines begin filling up simultaneously. We'll speed this along because, again, these experiments take longer and longer each time to run. And there we go. Let's see what our final input time was. Right there. So when we're feeding 3 machines off the same rail, we get a total input buffer fill time of 44 seconds and 18 frames. Let's repeat our frame math again. We have 18 frames times 0.0333 seconds repeating gives us a total of 0.5994 seconds. Add that to our 44 seconds, and we get a total of 44.5994 seconds to completely fill our input buffer. We divide that by 100 to get our per item time of 0.4459 seconds. We then derive our expected delay. Again, we're going to have to divide up our expected delay this time because we're splitting our rail throughput 3 ways for 3 machines, so each machine is receiving 33% of the total throughput of this rail. So we divide 480 by 3 to get 160, then we divide 60 seconds by 160 items to give us a total expected per item time of 0.375 seconds per item. We compare that to our observed time of 0.4459 seconds, and we get a total divergence of 0.07 seconds per item, which we can represent as a percent by dividing 0.07 by our expected time of 0.375 to get a total of 18% divergence from our expected time. So with this, I think it's safe to conclude that the more we segment a rail network, the more we introduce a linearly scaling efficiency loss to the ability of that rail network to actually distribute items to their endpoints. Now, why does this matter? Because these numbers seem fairly small and insignificant, but if we roll back to our original example of the 4 machines manufacturing chemicals. So here we're back in our original 4 chemical furnace example with no experimental setup. I just want these machines to run as they normally do to manufacture chemicals, and what we're going to do is we're going to start a timer and see how many wolfram powders actually enter this machine in a 10-second window. So there's a counter here, because it's a little bit hard to see. But in this particular example, we get a total of 11 wolfram powders enter this machine that's been subdivided 4 different ways between 4 different machines over this 10-second period. Now, I did take an average of this because I took different 10-second segments, and our average wolfram powder intake is about 12 items every 10 seconds. So if we do our math again to determine our total divergence, at 12 wolfram powder every 10 seconds, that is a per item time of 0.833 seconds. Now in this case, we're not going to compare this number to our ideal rail throughput or our ideal rail interval. We're going to compare this number to the required interval that this machine needs to receive wolfram powder in order to maintain 100% efficiency, because that's the number that we actually care about, which in this case requires 3 wolfram powder every 2 seconds. So if we divide 2 seconds by 3 items, we get a total of 0.666 repeating. So a wolfram powder needs to be entering this machine every 0.666 seconds or less, or this machine will eventually run out of wolfram powder. So if we compare that to our observed rate of 0.8 seconds per item, we get a total divergence of 0.167 seconds per item, which if we divide 0.167 by 0.666, we get a divergence of 25%. And as you can see, this compounds and causes our machine to quickly get choked out on wolfram powder when it should theoretically have enough throughput on a V3 rail to supply all the wolfram powder that this factory needs. So to roll this back to the original answer that I gave to this question, which was you can combine items onto a single rail, but it depends. You have to be conservative in your calculations of how much you can fit onto a single rail because of that 16 to 20 to potentially more % inefficiency on these rails as you join items onto it or break items off of it. The more junctions you have either joining or removing items from a rail, the larger your rail inefficiency, and that can really throw off your calculations if you are relying on an exact 480 items per minute or 240 if you're running V2 rails, etc., etc. So the two things that can complicate your calculations are either having a very low manufacturing cycle time, which in this case I think the smallest now that sulfuric acid has been changed from 0.5 seconds to 2. 2 seconds is the smallest manufacturing time in the game, so a small manufacturing time of 2 seconds or a large item requirement per cycle, so in this case 3 wolfram powder per cycle, we'll see that rail inefficiency choke out what should theoretically be possible on a V3 rail. So that's why I say it really depends on what kind of factory you're trying to make. Just something to think about if you are trying to super optimize your factories by combining as many items onto a single rail as possible to cut down on the number of rails that you need. So in my case, I'm going to continue using a dedicated item per rail for all of our factories. Alright, well with all that math out of the way, we can finally get to today's build. So the first thing we're going to do is we're going to go to the east here and find some more flat land to work on because we're a little overstretched with our current thermal situation here. So we're going to go towards this Wolfram Arch over yonder, where there is some fresh open land that's currently inhabited, but as soon as we clear out the natives, we'll have some flat land to be able to do factory on. There we go, some vacant property just went on the market, and I think we'll be buying. So there's a ton of land here to set up the factory that we're going to be working on today, which if we look over here in Rupture Planner is going to be the remaining metal fabrication in our mega press stack here. So we have reinforced frames, Goethite lattice, and reinforced housings. Now fortunately, all 3 of these recipes share some common ingredients, specifically titanoferrite ingots and wolfram steel ingots. So we'll actually be able to share some of our input materials between these 3 mega presses, 3 mega presses, and 4 mega presses here. So this will be an interesting interconnected factory with 3 outputs. So the first thing that we should do is throw down a mega press to preview these recipes that we're going to be building. We've got reinforced frames, which is 4 tubes, 4 titanoferrite ingots, and 2 titanium beams every 5 seconds. Reinforced housing, which is 1 titanium housing, 4 wolfram steel ingots, and 3 wolfram plates every 4 seconds. And Goethite lattice, which requires 2 Goethite ingots, 2 titanoferrite ingots, and 2 wolfram steel ingots every 3 seconds. So we have a number of common ingredients here. But before we can start to lay out our factory for these, we're going to need to unlock the recipes. So let's take a look in our recipe station to see how much of each material we're going to have to cram into the computer here. So reinforced frames, we're going to need 500 titanoferrite ingots, 600 tubes, and 800 beams. Reinforced housing, we're going to need 500 wolfram steel ingots, 600 titanium housings, and 800 wolfram plates. And then Goethite lattice. Luckily, we already had the blueprint for this. I don't remember exactly where we got it. That's going to require 600 Goethite ingots, 400 titanoferrite ingots, and 400 wolfram steel ingots. So a whole lot of everything. So let me gather up these ingredients, and we'll get these unlocked, and then we can actually start our build. We'll do titanoferrite ingots, wolfram steel ingots. I guess we could do one at a time and I can just change the recipe. So we'll put down a storage depot in front of each of these. I don't really feel like running back and forth across the map for all this. So we'll just do beams, especially with how bad the lag is getting. The longer I can stay in one place, like you can even see here, just moving the drone camera around in a single area, you get these like hard stutters. It's getting really bad, and I'm hoping that we can kind of finish up this season before it gets unbearable, but we're starting to get there. So I'm going to set this to, our first ingredient is going to be titanoferrite ingots, which we should have under T, there we go, TF ingot number 1. So we'll pull that down. We'll set this to titanoferrite ingots. This one we'll set to wolfram steel ingots. Down in here in the W's was ingots. We'll set this to wolfram steel ingots. And then we'll set this one to goethite ingots. Ging TX5. And there we go. So we'll let these fill up, and then I'll grab these and stuff them in the computer and unlock our first recipe. Okay, here are the ingredients for recipe number 1, which is going to be goethite lattice. So here's our goethite ingots, our titanoferrite ingots, and our wolfram steel ingots, plus our blueprints, plus our data points. Boom, number 1. Next, we'll change these receivers to tubes and beams, which should be down here in the T's, tubes. Overwrite the connection, turn this back on. We'll switch this to receive tubes. This one will change to beams, which is T for titanium beams, not B for beams. There we go, titanium beams. Yes. Turn the machine back on. Set this. Oh, we need to grab this first. Titanium beams. There we go. Okay, here are the remaining 200 beams to unlock reinforced frames and our data points, and there's recipe number 2. And this should be the rest for our final recipe here. 500 reinforced housings, 800 wolfram plates, and 2,000 data points, and we have unlocked all the recipes that we're going to need for today's factory. So let me clear all this out before we get started. So we're at the point in the game where we're going to be bringing in all the ingredients that we're going to be building with via cargo receivers. So we're going to need 10 of these guys in total. We're going to need 2 for titanoferrite ingots, 2 for wolfram steel ingots, 2 for wolfram plates, 1 for tubes, 1 for titanium beams, 1 for titanium housings, and 1 for goethite ingots. Now, we're not going to put all 10 of these together because not every factory is going to be using every ingredient that we're flying in. So what we'll probably do is group our receivers by our mega presses. So, for example, our goethite lattices use 2 materials that are also used in 2 other factories. So we'll group together 5 receivers that are going to be used by our goethite lattice mega presses, and then half of those materials will also be used by our mega presses for reinforced frames, and then we can put our other 5 receivers on the far end of that to feed into our downstream factory. So we'll start by placing probably 3 along the bottom and 2 along the top like we did for our resin factory. So we'll start, let's see, does this have a downward incline? It does have a bit of a downward incline, so we'll bring this down by 1. And we'll go to, say, here. Lock our Z. We'll do 1, 2, 3. Then we'll place our mega presses. And we'll space these out by 1. We go up here. We'll space these out by 1 because these are deeper, so I want to make sure that we have enough pillar support. So we'll put pillars in between each of these. So we'll do 1, 2, 3. We'll place down some supported platforms on the corners of each of our mega presses. Like so. And then for our cargo receivers, we know that we can just go directly in the back here. So we'll do 1, 2, 3, and 4. We did this layout for our... Oh, you guys are noisy. For our last factory. Bring these up by 2. There we go, and then we'll put down mega presses on top. Spin these around. We do have to put platforms on these. There we go. Mega presses on top. Spin it around. Lock our Z. 1, 2, 3. And then our cargo receivers will need platforms again. Like so. And I think for this one, we're going to need an additional platform right here. But if we bring this up, we can now place 1 and 2, just like this. So these two and these two will be grouped together. So this will be like titanoferrite ingots. This will be wolfram steel ingots. They'll combine or modulate their outputs together. And this will be our odd man out for goethite ingots. So we don't actually need this guy. This pillar here. So this will be our machine layout for our first factory here for goethite lattice. So let's throw down some rails. We're going to want... Well, I guess I'll do our machines first, and that will inform what our rails need to look like coming out of our receivers. But we'll do our usual alignment here. So we'll go down 1, 2. We'll place 3 of these. 1, 2, 3. We'll go up by 1, 2, 3, and we'll go up by 1 again. 2 and 3, just like that, and we'll repeat this up top. And we'll start with the one that we have already. Lock our Z. 1, 2, 3. We'll bring this down by 1. I wish this would not change your or reset your Z when you change the height of the railhead, but it is what it is. And we'll bring this down one more time. Bring this back up again one more time. Lock our Z. 1, 2, 3. Now, from here, we're going to want to rail modulate these two and these two together. So we'll bring this down to, say, here. And this is going to be our lowest setting. So we'll go down by 2. Place 1 here. And we'll place a matching rail support in front of this receiver. And then we can go out from here into our modulator. So these will be combining their 240 theoretical outputs into 480 theoretical. We'll come into this connector, go up into our mega press, and then we'll wrap around with our half wave pattern. You've seen all this before. This height is off somehow. That's going to annoy me if I don't fix that. 1, 2. Bring it down. Bring it to the right. There we go. And now to bring this up top, we're going to use our multi-rail method. Hopefully, we might need to space this back a bit. Let's see, if I bring this down by 1, 2, can we half wave around this? We can. And we will not need to bring our goethite ingots up, so we don't actually need all 3 of these. We're just going to need to bring, say, titanoferrite ingots up, and then we'll need to bring wolfram steel ingots down. So we'll also need to go from this connector to one of these, and since this taller one's going to be in the way of this guy, we'll probably end up using this top connector here for our wolfram steel. So I'll run this backwards. Like this. Bring this into the right-hand side for each one of these. And then this middle lane will be our goethite ingots over here on the left. So we'll come here. We'll throw down a rail support. We'll bring this down by 1. Send this to the right. And then we'll wave this through. There we go. Bring these up into our machines. 1, 2, and 3. So there's all of our inputs that we're going to need for our goethite lattice. We do need to connect this up top, but theoretically we have a rail route or a rail solution for all of our inputs here. So we'll come up here, and we're going to need to do the same here. Now, it doesn't technically matter, but I'd like to keep this at least consistent. So our top rail here is going to be our wolfram steel or titanoferrite, however we decide we want to divvy this up. So we'll probably try to keep that the same on top here. So we'll bring this into here. We'll send it to the right. Connect all these up. And we'll want to bring this down into this connector here. Oh, actually, I need to put a multi-rail connector, multi-rail support up here first. I guess we'll bring this down. So now we can bring this into here. Bring this down. I missed. It moved at the last moment. Bring this down. And then bring this up. So you're coming down via this rail. We need to bring this into here. Perfect. Okay, so now we can send... Do we need to do that? That's not right, actually. We only need to bring one of these to a different level. So let's delete this left-hand side. So we'll bring the top down, and then we'll just continue the left this direction, because it doesn't make sense to put our extra row of mega presses on the second level when there's a perfectly good floor here. So we'll continue our bottom rail to the right for whatever ingredient winds up being needed in this next factory here. And then we'll bring this down here and repeat it in these machines. And we need to get these connected to our receivers. So we'll take a rail connector, well, a rail modulator. We'll bring this up, flip it around. We'll bring this down 1, 2. And we'll bring this into the left-hand side, put a rail support right here. And it just occurred to me that we will actually need an extra receiver up here to this height, because this factory is going to have one extra ingredient that is not available in the downstairs receivers. We'll deal with that in just a moment. Bring it to the right, send this up, wrap it around. Continue this down the line. Just like so. So, onto our extra receivers here. So, let's think about how we actually want to lay this out, or which factories we want to be which. So, we know the bottom is going to be Goethite lattice. So, we're going to have, say, wolfram steel ingots along the bottom here. So, wolfram steel is going to be fed this way. It's not going to loop over the top. It's going to continue to the right. So, if wolfram steel is on the bottom, this factory here that we haven't built yet will need to be reinforced housings. That makes these 3 mega presses here our reinforced frames, which I guess makes sense because if this was reinforced housings, this would need to be 4 mega presses instead of 3. So that's a bit of a no-brainer. Overthought that one. So if these 3 are reinforced frames, we're going to have titanoferrite ingots coming in here, which means we're also going to need additional receivers for tubes and for titanium beams. So we'll need an additional 2 receivers here. So let me rebuild this pillar that we had in the back that I so callously discarded. Platform on top, and then we're going to need another one next to this. So let's put an additional supported platform. Lock our Z1, 2 right, of course, right where there's a plant that we can't get rid of. So I guess we'll put this here. Hopefully that extends our support base enough. Platform. And yeah, we'll see how this works out. So let me grab a cargo receiver. We'll lift this up. And then we'll put one directly next to this. It's just enough. Perfect. Okay. So we have one extra connection here that's not going to be needed. Let's get rid of this. This was throwing me off as I was looking at this. So we have our titanoferrite ingots going to be coming from this way. So this is actually backwards. we'll need this to go down instead of this bringing this up, because wolfram is going to continue to the right, and then titanoferrite is going to be looping down. So instead of taking this, we'll actually need to run... Which way do these are running to the right? This is the way they need to run. We'll run this to here. This will run down to, I guess, here, because this row is running to the right here. So we'll run this to here. That's fine. That all works out. We're just going from the outside lane to the middle lane. So we'll bring our titanoferrite in from the right, loop this around, and this will become the middle lane, which then becomes the top lane. So this will be running to the left here. So I think that's all correct. So we'll need to now just loop in our extra 2 receivers here. So we have one set of rails here already that's running to the right and is not connected to anything, and then we have the middle lane, which is not set up at all. So let me connect up our middle lane, loop this through, connect it to our presses. There we go. So our middle and top rows are running to the right. These will be connected to our 2 new receivers here. So we're going to bring in a rail support for each. We'll drop... Oh, we don't have enough support for this. That's unfortunate. But we can make some support by putting a supported platform right here. Bringing this pillar up 1, 2, and that should give us support for a rail support right here. We'll bring this down 1. And then this guy will be at full height. So we'll bring you back up 1. There we go. So, receiver into support. Pillar support to the right. Receiver into support. Pillar support to the right. There we go. I had to adjust on the fly, but I think this is all correct now. So you're being modulated, you'll be wolfram steel. You're being modulated, you'll be titanoferrite. Titanoferrite runs to the right.
Activity detected. I recommend
At least we're done with the building and we're just doing review. So it runs to the right, hits the outside lane, comes down into our middle lane, then goes to the left. Wolfram steel proceeds to the right. This is going to continue forward into our next factory. So I think all of our wiring work is done here, at least on the input side. So we'll wait out the rupture and come back and finish up wiring the output side of this, and then we can set our receivers and our recipes and apply some power. Okay, let's get back to this. So let's set our recipes first. So down here on the bottom, we're going to be making Goethite lattice. So we'll set our 3 mega presses to Goethite lattice. And we know up top, we're going to be making reinforced frames. We'll set those here. Reinforced frame, and reinforced frame. We just set up our receivers. So we said up top here, we're going to be bringing in titanoferrite ingots along the top. There they are. TF ingot TX1. We'll call this TF ingot RX1. And you will be TF ingot RX2, TF ingot RX2. There we go. Then we're also going to need tubes. Tubes TX2, so this will be tube RX2. And titanium beams. T-beam TX1 to T-beam RX1. There we go. Now downstairs, these will need to be wolfram steel ingots. So we'll go all the way down. We'll grab WS ingot TX1, WS ingot RX1, then WS ingot TX2 to WS ingot RX2. And here we have just regular old Goethite ingots, which is going to be GING RX5. G ingot RX5. Okay, here's our receivers and our recipes. Now, what does our output look like? This is running every 3 seconds. So 60 divided by 3 is 20. So we're making 2 times 20, so each one of these is outputting 40 per minute, and we have 3 of these total, so we're making 120 per minute total, so we can modulate all of these onto a single rail. And send these... That's actually a good question. Do we want to send these to the left or to the right? Because we're going to have another factory over here. So we'll probably want to send these to the right, and we'll set up our storage depots behind our drone receivers here, our cargo receivers, and then we can do our dispatchers off in this direction, I'm thinking. So we'll collect these in this direction, actually. 1, 2, and 3. I guess technically this doesn't need to be a modulator. Doesn't really matter, but... I'm a bit of a perfectionist, if you weren't aware by now. So we'll send these to the right. We'll collect these into... Do we have enough height? We probably don't have enough height for a storage depot V2, but that's fine. We're not really making that many of these that we need that much storage. So we'll collect these, I guess, right here is fine. We'll do one here. We'll do one here. Just tall enough. We'll come into this side. Set this to Goethite Lattice. And then we'll do the same thing. Well, let's check our recipe, but I'm fairly certain it's going to be less than 480. Let's see, 5 seconds, so this is what, 12 per minute times 3? That's 36, so yeah, way less. We'll collect these in modulators and send them to the right. 1, 2, rail support for 3. Send these along. Just like so, into our storage depot. We'll set this to collect reinforced frames, and then we'll worry about our dispatchers later, but this should be everything that we're going to need to get this factory online, I think. So let's apply some power. Wind turbine V1. One of these days we'll get around to unlocking V2. Where do we want to put this? We'll lock our Z here. We'll bring this to here, I suppose. And we just need a couple of supported platforms to connect this to the actual factory, and there we go. So, let's wait for some materials to come in. Simultaneous arrival. I love it. Alright, let's make sure everybody is happy. I see pressing up top, so we know we're getting all of our items in here. We still... Nope, we have green lights now. Okay, so everybody's getting everything that they need. And we seem to be getting enough of it. Titanium ferrite ingots are filling up somewhat slowly, but we're gaining rather than depleting, so we know that we've got enough of our input flow. And here's our Goethite lattices. Let's head up top. Ugh, there we go. And here's our reinforced frames. Incredible. Okay, so there's 2 of our 3 factories we're going to need in this location. Let me patch up the holes in the floor here. Just for style points. Okay, and now we're ready for our last leg here. So we're going to need 4 mega presses for reinforced housings. So let's slap down 4 more mega presses. We don't... These guys are haunted. Here, chase them off with the drone. Get out of here. There you go. Oh, why aren't these covered up? I guess the rupture is technically not over yet, or the recovery. The ash fall. So we don't need to space these out because we're not going to have an extra row on top of this, I think. We may need some extra manufacturing here once we get into whatever these are going to be feeding into as input ingredients, but for now, we're going to squeeze in 4 factories or 4 mega presses right next to each other, which is probably the best way to go about it, because I don't think you can actually stack buildings on top of nodes like this. Like if I put down, this may have been fixed in one of the hot fixes, but at one point you were not able to build upwards when you're building over the top of nodes like this. So let's see, if I put this up here, well, they don't seem to mind anymore. It says it's not stable, but it might just be because we don't have enough pillar support. Let's see. We'll do one here. The spacing is incorrect, but this is just temporary to see if this was fixed. Okay, that was fixed. So that was a thing in early access, because I remember running into that issue while doing my 100% scanner efficiency video. But that seems to have been fixed in Update 1. So if we need to, at some point we can come back and we can space out pillars or something. But I think we'll just roll with this layout here, because we don't really have much extra horizontal room to work with here. So we're going to be taking our Wolfram steel ingot feed, which is currently coming into here. And I do think we may actually want to bring this up, because we do need to bring in some additional receivers. So how do we want to lay that out? We have one additional tile of depth we can work with, because cargo receivers are only 4 deep and the mega presses are 5, so we can use that to squeeze in an extra set of pillars, and then we can bring. Well, we can always just put our receivers over the top of this as well, because we have to worry about this rail here. It's not impossible to bring this up and continue it, but the whole reason we laid these rails out like this was with anticipation of having these in this location. You know, it wouldn't be impossible. Yeah, let me test this before we do anything. So I'm gonna put down a supported platform here and here. We'll bring our pillar supports up 1, 2. We'll cap these off with platforms. We'll bring our mega press up to here. And then if we continue our rail connector layout, so we will put this guy right here, down 1, 2. We would need to bring this rail up to here. You know, it does work, and it makes this kind of satisfying. These rails actually like twist around each other like a DNA, which is kind of neat. So maybe we will bring these up to the 2nd floor. Yeah. That's going to make squeezing our receivers down here a bit easier than building them over the top, because then we have to stick these pillar supports for the receivers back an additional level, which means that we'll then have to bring our output rails from our mega presses back another level past that. So I think this is probably going to be the most compact way to do it. So let me bring these up to the top here. So we'll need to put a supported platform every 4 tiles here like this. So there's machine number 2. There's machine number 3. And then this one's going to be in the ground, so this is going to get a raw pillar. So we'll go 1, 2, 3, 4, 5, and then we'll bring this down to this level, lock our Z, and put our pillar here. And we can put our 2nd pillar on. All the way across, and now our mega presses, we flip these around and lock our Z, can live right here, just like that. And then our receivers can be nice and snug down below. So we're gonna need, we have 7, 1, 2, 3, 4, 5, 6, 7, so we need 3 down here. For, what does this recipe call for? Titanium housings and wolfram plates, right. So it's 2 for wolfram plates, so we'll do 1 and 2, and then we'll have 1 for titanium housings, like so. And probably what I'll want to do is loop these up like this on this side, so I'll probably justify this to the right instead of the left. We'll put this guy right here. There might be some interesting rail work here with how this elevation comes up, but it shouldn't be too difficult. So let's modulate. Let's see, our wolfram steel ingots are going to be coming in on the bottom level, so we're going to be using the middle and the top levels for our other two ingredients. So we're going to need a rail modulator at medium height, so down 1. And you're going to go, let's lock our Z here, because this is going to need to be pushed into the ground. You're just going to go here. And we're going to need a rail support here, down 1, which should make it level with our modulator. It is not, somehow. That's definitely default height. That's definitely down 1. How did you get up so high? Let's try that again. Rail modulator. Down 1. Rotate this way. Lock our Z. There we go. That looks better. Alright, output to the right. These will be our wolfram plates. This receiver will get a single rail support at default height. These are going to go to a multi-rail right here. We still have our Y locked, or our Z locked, so this should be the correct height. We'll bring this to the right. There we go. We'll bring a multi-rail up. I don't think I brought that forward enough. Yeah, because these are right justified, so that multi-rail support's actually going to be where we have a rail connector, so we need to move this one to the right. If we can. Actually, we may need to left justify this last one here, because if I push this one to the right, I think our output rails are going to impact this. And while it's okay for your rail supports to impact ground elements, the game doesn't like it when your rails impact ground elements. See how it's red there because we're going through that rock, so we'll need to put this in this exact location, which is fine. We'll just need to keep that in mind when we're placing our rail connectors up here. So we'll bring this up. We'll loop our middle 2 rails up top. 1 and 2. And then we'll place our rail connectors for inputs into our machines. Nope, I'm way off. So we'll bring this up 1. We'll place 2, 3, and in this case we're going to bring these to the left one, so our 4th will actually be right here. Then we'll go up by 1. 2, 3, and 4. Then we need to bring this down to the bottom. 1, 2, and 3. Well, I guess 2, 3, and 4. So there's all of our rail connectors for our inputs. So we already know that we have our wolfram steel ingots coming into here. So this will loop around. Now this may actually be an issue to getting this into this last guy here, but we can do, since this is the last stop, we can just do it like this. We'll bring each one of these in. Getting some stuttering again. There we go. And then everything else is going to be coming from the right here. So we've got our loops coming up. We'll grab one of these and send it directly in. And then can we bring this one down? We cannot. What I should have done is bring this down to this level and then go up. So let me do that. We'll bring this down. 1. And that should allow us to loop around this guy. So let's bring these back up again. There we go. Then our middle rail will go up. And then these, once we're done auto-saving, these will need to go to the left. How do I want to do that? There we go. Yeah, that works. I think that's how it's supposed to go anyway. Just, I was looking at it. I'm not used to running the rails from the right to the left. So yeah, we take our forward-facing output and then go into the next side input. So just like this. Stopping there. Okay, so there's one set. And then these come in, and then we run from the left like this. All the way through. Run in all of our inputs here. And this is a different factory, so this should be it. That's all 4 of our machines wired up to all of our ingredients. I think. Yeah, this is coming from the left. Okay, yeah, so we're all good here. So let's set our recipes and our receivers. We know this is going to be titanium housings. T-House TX1. T-House RX1. These 2 are going to be Wolfram plates. We have WPLT TX7, WPLT RX7, and WPLT RX8. And it wasn't until this exact moment that I considered that we might need to buffer some of these. I guess we'll see what happens. These are somewhat slower manufacturing times, so we may not need to. The extra manufacturing time tends to allow some extra time for items to build up in their internal buffers here. We'll set these to, what is it, reinforced housings. Reinforced housings. Reinforced housings, because we know for our first 2 factories we didn't have any issues with inputs. Everything was, the flow was sufficient. We're mega pressing already, so I assume we're okay. Stuff is flying in here. Let's take a look. Yeah, these are 4-second manufacturing times, and other than our Wolfram steel ingots, our inputs are pretty low. Our Wolfram plates might be an issue, but we'll keep an eye on it. We did not set all these. You need to be reinforced housings, my friend. Here comes his stuff. We'll keep an eye on this one. Yeah, I think we'll be just fine. Okay, now I didn't set up our output rails, so let's take a look at our recipe while we're watching this guy. So this is every 4 seconds, so that's 15 cycles per minute with times 1. So each one of these is producing 15 reinforced housings per minute. So that's definitely less than 480, so we'll grab our rail modulators. We'll send these guys... I don't know if I want to go all the way to the left, given how tight up against this wall we are, so I may do something like... let's go ahead and bring these to the right. Bring these to the right, collect them downstairs here, and we'll set our dispatchers on the ground. So we'll modulate these to the right. Lock our Z. We'll need 3 modulators and 1 rail support. Connect everything through. There we go. Now can we go directly down? We can. Perfect. Okay, let's set our storage depot to receive reinforced housings. And there they come. Okay, so let's take a look at Rupture Planner so we can see how many dispatchers we need to set up for each one of these factories. Alright, for reinforced frames, we're going to have 2 outputs, or 2 dispatchers, and those are going to anti-radiation covers, and way down here to heat shields. Okay. So 2 for reinforced frames. For Goethite Lattice, we have 2 outputs. These are going to... what is this? Pseudo rubber insulators. And then down to Uber filament. Okay. Put this back in its place. And then down here towards the bottom, reinforced housings are also going to 2 locations. Anti-radiation covers and... way down, cyclotron. Whoa. Okay, so 2 for each. That makes this nice and easy. Cargo dispatcher. Now I do need to either bring this storage depot down or space our second set of dispatchers different vertically, because these are a bit taller than the drone or the cargo receiver. So if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units of vertical offset. So those will be a bit taller than the supports that we currently have, but it's not the end of the world to just bring our rails up a little bit. We do have to put down some differently spaced pillars though. So at 15, that's going to be 12 and 3. So our offset in the back will need to be 1, 2, 3. We'll do 1 there, and if we're building, well, that should be fine, right? These are 4 wide, so it'll be 1, 2, 3. Oh, that's actually, well, it should be all right. We're going to put 2 pillars. It's not going to align exactly to the back of a dispatcher. Oh yeah, we can't actually build that. Can't build when active. Right, I can build there if we wait for the rupture. Which I'll probably do, just because I don't want to have to do anything weird or space this out. I want these to look nice and level. So we'll leave this one out for now. We'll build these up, put a platform on top of each. I'll bring this one in 1 because we're actually out 1, and then when we're able to build here during the ashfall, I'll bring this back in by 1. Right now, we should be able to bring this guy up to here. Not stable. What if we connected this all the way through? Because we should have a distance of 3. Ah, there's our problem. We're just shy. Okay, so if we just build 1 more supported platform back here at a height of 1, 2, and 3. Pillar support. That should be enough to bring this guy up to there, which means that we will need to wait for asphalt to put these 2 in, because this is not going to have enough support unless we can put another supported platform right here. So we'll have to put this one on pause for just a bit, but we can at least get our rails ready. So we'll take our outputs here and here. We'll take 2. Well, this bends into the back here without intersecting this pillar. It will. Perfect, because I want this output and this output for our dispatchers. We'll do the same thing here. Bring this into the back. And we'll grab you. And you. There we go. And loop 1 out, and then we'll do our second set during ashfall. So there's half of our dispatchers for these two factories, and then this one should be much easier. We'll throw down 2 cargo dispatchers here and here. And we do need to see if I can move this into the back, just to simplify our rails. Can you go here? You can. Perfect. We'll do multi-rail 3 here and here. Grab our rails. Send one into here. Bring the other one through. And there we go. So let's set these guys up. These are going to be for Goethite. Oh, I forgot where I was physically standing. Okay. This guy is going to be for reinforced housings. So this will be our housing, RHSNG, TX1. Reinforced housings. And then RHSNG reinforced housing TX2. Reinforced housing. So you're set up. We know this one is Goethite Lattice, so this will be GLTTC TX1. Accepting Goethite Lattice. Right up top. You're going to be reinforced frames. So our frame, why not? TX1 reinforced frame, and then again we'll set up our extra dispatchers in just a bit here. But this is going to complete these 3 factories combined into 1 factory. We'll do a little scan around here. Nothing mind-blowing as far as visual design in this factory, but yeah. This point of the game becomes much, much easier when all you have to do is hook up a bunch of cargo receivers to a bunch of manufacturing buildings. So we should be able to get through more individual items this episode than we normally do, because each individual factory is getting quicker and quicker for us to throw together. So I'm going to take a little break before we head into our next factory, and that'll give us time to wait for a rupture to happen so I can set these 2 up. But we'll meet back up when it's time to head on to whatever our next factory is going to be. So I'll see you in just a minute. Alright, let's take a look back here in Rupture Planner, because I'd like to continue working our way through our Mega Press tier. So looking at our Mega Press list, we have valves left. We have, I believe, impellers is done. We have impellers mostly done on our turbine line, and we have 1 other dispatcher set up to send impellers to pumps. Plastic we can't do until we get access to Powerium. Nozzles we can do, and then nozzles will unlock the path to valves. Making sure I can see all this. Nozzles will unlock the path to valves and also to generators here. We have turbines set up already, so I'd like to do nozzles, valves, pumps, and maybe eventually generators. I don't know if we'll get the generators because this is an assembler recipe, but we can start with our nozzles and our valves and our pumps. So let's start here at the beginning with nozzles. So for nozzles, we're going to need, it looks like, heat-resistant sheets, stabilizers. I believe blue is helium-3. Yeah, helium-3. So we'll set up 4 mega presses for nozzles here, and then we'll set up our receivers, pull these in, and then we'll probably roll right on from there into valves. So back in the game here, let's drop down a mega press just so we can see this recipe in-game. For nozzles, we're going to need 2 heat-resistant sheets, 6 helium-3, and 1 stabilizer every 5 seconds. Now we do need to unlock this recipe, so before we start laying out our factory, let's go take a look at the recipe station. Okay. Nozzles are going to require 200 heat-resistant sheets, 2,000 helium-3, and 100 stabilizers on lock. So this should be relatively easy except for the helium-3. But let me go gather these things up and we'll get this recipe unlocked. Okay, this should be the last of it. So 200 heat-resistant sheets, 100 stabilizers, 800 data points, and we've unlocked nozzles. So now we can start to set up our factory. And we'll probably stick this right in front of our existing factory. Again, we're going to need 4 of these mega presses. Mega press. Now, I should probably, before we place anything, we should probably work out how many of each ingredient we're going to need, but this is a fairly simple recipe. The helium-3 is going to be the largest part. So each cycle is 5 seconds. That means there are 12 cycles per minute. So we're producing 12 nozzles every minute in this mega press on our output side. On our input side, we're going to multiply anything that we need here by 12. So we're going to use 12 stabilizers per minute. We're going to use 24 heat-resistant sheets. And our helium-3 is going to be 12 times 6, or 72. And then again, we're multiplying all these by 4. So stabilizers is going to be 48 per minute total across all of our mega presses. We're going to have 96 heat-resistant sheets across all 4 mega presses. And then our helium-3 is going to be 72 times 4, which is 288. Which should theoretically be doable out of a single receiver for helium-3, but it's going to be pushing the limit of the throughput that we can get on a single machine, but it'll definitely need to be buffered. I guess we could try it out, because it's kind of straddling the line. I'd really try to calculate for 240, but theoretically with a dispatcher dispatching once every 20 seconds, if we can load a full stack of helium into every dispatcher, we should get around 300 per minute. But let's try it out. We can always add another receiver if we end up needing it. So we're going to delete this. We're going to put down 4 of these in a row. Starting, I suppose. And we do have some stuff in the way here. A forbidden build area. So we may want to start these in the same location that we started our previous row. So we'll come here. We'll lock our Z. Pull this out. 1, 2. Place 1 here. And then we're going to have 2, 3, and 4. Just like that. Receivers will have 3 for now. And we may want to consider buffering these. How do we want to lay out our buffers? Because these aren't quite deep enough. Well, they kind of are, because we do have 1 reserved tile in the back. So I try to do, when I lay out these lanes for our factories, I try to put a gap of 3 spaces in between each manufacturer, so that we have space for a rail support, a space, and then a rail support. So technically, these receivers aren't going to have a rail in the back. So if we push these back 1, we won't need this tile here for our receivers. So if we push them back 1, that gives us 2 spots, 2 tiles in the front to place a buffer for our helium-3. And if we're going to do that, then we might as well buffer the other 2. So we'll put 1 and 2. We'll buffer these just to make everything look consistent across this row. We'll come out of our receivers into wherever that went. Whoa, how did you get that connection? The targeting algorithm gets a little crazy sometimes. And we'll take out like that. The jittery frame rate and stuttering doesn't exactly help when you're trying to line up your placement. We'll take all these into our storage depots. And now we have our reserve tile on the front to send these to the right. So what we'll end up doing is taking these down 1, 2 in our normal layout here. Then up 1. And then up 1 again. And we only need a single rail support this time because at the moment we're not modulating anything unless we find out that we need some extra helium-3. In which case I'll probably put another... Is there a room for another receiver here in the end? There is not. We would have to push this back a pretty significant amount, which is not the end of the world. It's just going to ruin our, like, nice clean lines. But if it comes down to that, it'll come down to that, but it's not the end of the world, so we'll run our rails out, please. Target correctly. Connect to what I'm looking at. And then we'll set up our rail connectors. We'll do down 1, 2. Lock our Z. 3 and 4. Raise this by 1. 2, 3, and 4. And 1 again. 2, 3, and 4. We'll bring each of these to the right. You to here. You to here. And you to here. And then we'll just use our wave pattern to bring these all to the right. Through all of our machines. Like that. And then we just connect up our inputs. 1, 2, 3. 1, 2, and 3. There we go. Okay, and then we know that our output is not going to be exceeding a V3 rail, so we can go ahead and wire that up. Now, I would have preferred to do this to the right, like we did over here, but again, we're using this for receivers, cargo receivers here, so we will just modulate these to the left instead. Go modulators. All the way down. Yeah. Send everything down. There we go. We'll put a storage depot here on the end. Let's see, if we go back to here. Bring this into this side. Does this give us enough room to put our cargo dispatchers in the front? It does. So we can distribute this along this way. That'll be kind of convenient. I don't know how many of these we're going to need yet, so we'll hold off on that, but we should have everything here set up so that we can set our receivers and our recipes. So we're going to do... I guess let's do helium-3 in the back here. That way it's going to be a little bit easier if we have to add a second receiver. We don't have to bump everything up one. So we'll set this to our helium-3 line. Somewhere. Here we go. HE3 TX16 to HE3 RX16. You're going to be stabilizers. Stabilizer TX1 to STBLZR stabilizer RX1. There we go. You're going to be heat resistant sheets. HR sheet TX2 to HR sheet RX2. We'll set all of our storage depots, heat resistant sheets, stabilizers, helium-3, and then nozzles on all of our mega presses. Nozzles, 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 and finally our output depot is collecting nozzles. So let's find somewhere to bring power through. Let's say right here. We've exceeded the capacity of our one wind turbine. So we'll add a second. That brings everything back online. We crush that plant. Interesting. As long as you've already got a building on it, it doesn't seem to mind if you add another building on it. So we'll wait for our items to come in here, keeping a particular eye on our helium-3. There we go. Now, given how quickly each one of these machines is going to be guzzling down helium, it's like 6 per cycle, we're probably going to run inefficiently. We're going to get choked out until we get our full internal buffer here. But we were at 8 previously. Now we're at 10, so we are at least gaining helium-3. So we're not under delivering just yet. So far, so good. So we'll keep an eye on it as more shipments come in here. And it looks like everything else we're good on. Okay, so we are getting a little bit of choke out here. Yeah, I think I'm going to make the executive decision here to add a second receiver for Helium-3. All of these machines are running at about 85% efficiency, which will probably be enough if we were to look at Rupture Planer again. We probably don't need all of these to be running at 100% efficiency to meet our downstream demand, but I like to see 100% efficiency, so I'm going to... I ran a little bit too far. I'm going to put... What am I going into support? Not adding a second deck here. I'm adding another cargo receiver here to the end. And we're gonna modulate these as soon as auto-saving is done. We're gonna modulate these together, and what I'll probably do is when the next rupture hits, I'll come and I'll destroy this receiver, and we'll move it up so that it's square with our other receivers. But for right now, I'm gonna push this back 2 tiles here. And then we don't actually need to modulate these if they're coming into a receiver here, so we'll just do this for now, because we are gonna move this, and just so that it's on camera here, during the last rupture, I did go and add our second dispatchers here for our previous 2 factories, so those are all squared now. So let's set this up for our other, or one of our other remaining Helium-3 dispatchers. Actually, well, no, there are 2 left, so 17 and 18. So we'll take HE3, TX-17, or RX-17, RX-17, I wonder how many more places we're going to need Helium-3. That's like sulfuric acid in that it goes to so many different recipes. But this should definitely set us up with 100% of our Helium-3 needs. There we go. Now we're getting double the Helium-3 input, saturating our rails. So now if we check out our mega presses here, we should see these numbers start to shoot up. 11, 13, 15, yeah. And there doesn't seem to be any end to it. In fact, we're actually building up some internal buffer. We have so much coming in now, so we're definitely good now on Helium-3. We just need to fix the positioning of that receiver at some point. I'm going to come down to the end here and reconnect this. I guess that's fine. I'm trying to think. We have one more, at least one more factory, if not 2 more factories that I want to squeeze in here. But this is fine for right now. And we'll turn this back on. I don't know what the point of this power button is if it's not actually going to stop items from moving through it. So that's fine. So this will be our nozzle factory. So next up, we're going to do our 4 valve mega presses. So we're going to need to unlock that recipe as well. So before we even get into the laying out of the factory, we pretty much are going to use this as the exact template, but 1 level up. So let's go take a look at the recipe station. Recipe station says for valves, we're going to need 200 nozzles, 300 more titanium housings, because apparently I dumped some extra titanium housings in here at some point. So 300 titanium housings, and then 300 titanium rods, all easily done, and we have the blueprint available. So I'll set up some cargo receivers here, or I'll borrow some of these from our existing line here to get these set up, and then we'll be ready to factorize. Okay, this should be everything that we're gonna need. Mega press. Let's deposit 200 nozzles, 300 titanium housings, 300 titanium rods, a blueprint, and 1,000 data points, and we're off to the races. So, I put some extendable walkways down just to level out this factory here, but I did leave some openings for where we're going to have our pillars. We have convenient placeholders for our supported platforms. We're going to lock our Z here. We're going to put one at each corner of our mega presses. Which I will need to move this for. I knew there's a reason that it shouldn't go there. That's fine. We'll worry about the placement of that when we get the top level onto this. I'm going to put 2 here. And I guess I kind of goofed this one, huh? So we'll put one in this front corner. Right here, and then I guess we'll just have to put one here in the back. I don't think that should mess up our pillar support layout too badly. So let's put 2 pillars on top of each one of these supports. Like so. We'll drop a platform onto each of these. There we go. Copy our mega press and see if we can bring this up. There we go. We'll lock our Z here. 2, 3, and 4 mega presses. Now we're going to need, well, let's take a look at the recipe. Our heat is climbing up. So here we're making valves. We're going to have 4 separate inputs. Luckily, this is a very slow recipe, so even though we've got some high numbers here, like 3 titanium beams, this high manufacture time is going to offset that so that our actual intake isn't too bad. So this is going to be 6 cycles per minute. So everything here is going to be multiplied by 6 and then multiplied by 4. And our worst offender is going to be obviously titanium beams at 3 per cycle, but even at 3 per cycle, that's 3 times 6 times 4, which is only 72 per minute across all our machines. So all this stuff is going to be easily squeezed onto single V3 rails. In fact, we could probably consolidate multiple of these onto a single rail if we wanted to go back to our original segments from this episode. You know what? Just for the sake of mixing things up, let's try it. So let's calculate. This is the perfect machine, the perfect recipe for us to play around with squeezing things onto a single rail. So let's start with our 1 per cycle items here. So we're going to have, let's just join these together as 2. So if we do 2 times 6 is 12, 12 times 4 is 48. If we double that for our titanium rods, that's 96. And then if we add in the 72 from our titanium beams, that's what? It's only 168. So theoretically, we should be able to put all of this across all of our machines onto a single V3 rail. Let's see if that's actually going to end up being the case. Because again, the more junctions we add to these, the more it introduces tiny losses in efficiency. So if we're only doing 1 rail, we should be able to just rail modulate these, which are technically faster than rail connectors. Because we do want to make up as much efficiency as we can if we're going to be losing some efficiency in our junction points. So we'll bring these to the left, run these straight forward. There we go. Modulated. Now we're going to need 4 separate receivers here, so we are going to need to put some pillars probably in these voids here. So we'll take out these extendable walkways, and we'll drop in some supported platforms. If I can find where my platforms went. There they are. 1. Let's do 2 and 3. And then we're going to need another one down here on the end, but I'm a bit too far away. And we're putting these on the right corner. The forward right corner, so like that. Of course, it's going to be right in the way of our rail, so we'll have to move this again temporarily. Let's bring this forward, I guess, into a rail connector for right now. Just so it's out of the way. Oh, right. No, that's fine. That's fine. We just need this out of the way to put a pillar here, and then this will get moved forward in a bit. So we'll put 2 pillars on each one of these. 1, 2. 1, 2. 1, 2. I do want to put back in the extendable walkway while I'm looking at it, or I'll forget about it. There we go. We'll cap these. And we'll see if this is enough support to place our receivers up here. It is. We do need to, I guess, add some... extend our base of support a bit. There we go. That works just fine. And then we're going to need, I guess, one more here on the end. Where can we put a supported platform where this plant is not going to be in the way? Right here. Yeah, that'll work. Okay. And then we definitely have enough support for our storage depots, so we'll bring these up. Actually, you know what? I don't even know if we need storage depots. The draw on this is so low, I don't think we'll be emptying these out fast enough. I guess just for the sake of making this uniform with the receivers down below, it can't technically hurt to have these here, other than adding additional heat dissipation that we'll have to account for with some extra base core amplifiers. So we're gonna be, I guess we'll modulate these on the input side as well. We'll just turn these in the opposite direction so these will look like this. So, oop, I had my Y locked, my Z locked, there we go. So put one in front of each of these. Except for here on the end where we'll put a rail support. We'll bring these to the right. Join them up with our other storage depots. And then we just connect modulator in to modulator out. Hook up our receivers. No. My cursor is pointing right here. Put it right there. Thank you. Okay. So far, so good. Now I need to remember what all's going into this recipe. We're going to have titanium housings. Titanium housings. T-house. RX2. I think it's like all the titanium things. So titanium housings. Titanium rods. Which we still have a ridiculous number of. Where are all these supposed to be going? I'm not quite sure at this point. It's been so long since we built that factory. We'll grab a TX5. T-Rod RX5. We're gonna have titanium beams. There we go. T-beam TX2. This will be T-beam RX2. And, you know, it just occurred to me that one of these inputs is going to be nozzles, which is, like, right here. But down there. It would be really silly to put a dispatcher just to send it to here. I guess we could, like, loop this back around on the backside and bring this over here. Let's see what we can do here. We can do a double layer of rails on the top side here, so we'll come down here to the end. We'll put a storage depot here in the end because we do need to put at least one dispatcher in to send these off to pump? Something else that takes nozzles. I think it's pumps. So we'll put the storage depot back in here now that we've got our pillar in. And actually, before I hook that up, I'm going to fill this with the nozzles that I have in my pocket here. There we go. Pocket nozzles. Did that get in there? It did not. Okay. Now we'll connect this rail to... Here we go here. That'll work just because I want these... I guess we only need one of these, but... Yeah. We'll do that instead. We only need one of these. That's fine. Okay, so we'll take that. Now we need to clear this rail. Give me your nozzles. Quick, take these. There we go. Uh-oh. I was too late. Okay, we'll let these burn up in the rupture. We'll drop this here. And we're going to take one of these and go up. And because... No, not a grenade. The drone, please. Because we're doing this on a single rail, we can't run this backwards So we need to bring this back around again down to there. In fact, the more I think about it, the more I might just put another dispatcher here for that. So let's just do it. Let's put 2 dispatchers here. This is so wasteful. But I only have to pay for it in base core amplifiers, and base core amplifiers are cheap and plentiful. Did I? Yeah, that's fine. We only have to go from here, and these don't push past this side, right? Yep, we're fine. So we'll put multi-rail supports here and here. We'll take our outputs from here and here. We'll run U to U. Send this forward. Run U to U. There we go. And these are, again, nozzles. So we'll call you Noz TX1. And Noz TX2. We'll set up our receiver to receive from Noz TX1. We'll call this Noz RX1. We're living a luxurious life where we no longer need rails to bring items 50 meters to the right. We just dispatch everything and then build a cooling tower to pay for it. So these are our nozzles. These are, well, I'm not sure now because everything is joined together when it shouldn't be. So these are beams. And these are rods, which means these have to be housings. So we should see all of this flow to the right. Did we set? I didn't set a recipe, so I'm not actually sure where these are going. I guess I set one recipe. These are for valves. Okay, let's see if our maths. We're definitely saturating our rails here. Oh yeah. Oh yeah. Even with the extra initial load from filling up the internal buffers here, the 10-second cycle is so long that these have no problem refilling.
If I don't drink something soon, I'm gonna die.
Such a whiner.
Nice.
This man's addicted to his gels. Okay, well, we know the output is definitely not going to be overly saturated, so we'll just collect these into rail modulators and then send them to the left. There we go. Actually, yeah, just to be consistent, I want this one to be a rail support. There we go. Send them down the line. Just like that. We'll drop our storage depot right here. We'll run these into the back, or I guess the side. Collect our valves. Here they come. Now let's see how many places these are going to need to be dispatched to. Valves are going to 2 locations. They're going to pressure tanks, and they're going to pumps. So we'll set up 2 dispatchers for these. We're going to need some platforms to support these with. Probably... Let's see, what can we get away with? I think we need, based on the receiver side, I think we need 2 platforms per. Well, that's good timing, because I need to fix our receiver down here. See if we can get this set up by hand before this rupture arrives. Can we do... I want to see if I could side support these. But I don't know if we'll have enough depth here. Let's see. Forget it. We're short on time. I'll just do our normal corner layout. 1, 2, 3, 4. Pillar supports. 1, 2. 1, 2. 1, 2. We need some platforms on top. Copy this. Oh, right, these need to be taller than that. Crap. These need to go up by 3. We're not gonna make it. Stop blocking the Y. Go down. 1, 2, 3. Lock that. That is not where I wanted it, but I'm just gonna roll with it. Now we'll break it. 1, 2. 1, 2. 1, 2. 1, 2. Platforms for everyone. Copy. Ooh, it got really dark all of a sudden. To bring this up. 1, 2. We made it! Actually, that one's wrong. That one's wrong. Bring it up, bring it up. Hurry! Like that? Like that. Go, go, go! No, train plant, no!
Rapture's core is unstable. Head to
My
safety.
eyes! Yeah! Alright. I'll see you in a bit. Alright, so the reason that I needed to get that on there before the rupture hit was because we're still way over our heat limit, and I wouldn't be able to place them for quite a while if I had waited until afterwards, but we should be able to place rails, right? Yeah, we just can't place anything that generates heat when we're overheated, so as long as these are pre-placed, we can manage our rails. So, where did we leave off? This is going to be lower because it's at a different, different height. These have to be taller, which is fine. So we'll set our multi-rails here. Let's set our multi-rails here. So we'll do one here. We'll do one here. We'll take outputs from here and here. Yeah, that works just fine. Loop this out. Loop that out. There we go. Now we can hand cool these so that we can get in and set them up. 1, 2, and then we'll also cool this guy down so we can actually see our items move. Well, they won't move until we get power back. I'll go do that in a second. So these are going to be valves, right? So this will be valve TX1. This will be valve TX2. Let's go get our power back online. 1 and 2. Actually, part of this is already cooled off. There we go. So all the stuff that we've hand-cooled is back online, so this should get our valve manufacturing up and running at least. Things are running. Buffers are filling. I like it. Way easier to do it on one rail than to do another set of 3. Oh. Ah. Frame rate caused me to just run right off the edge. So we're not... No, we are collecting. It's just immediately going out into filling up our dispatchers, which is exactly what we want. So we'll call this a completed valve factory. There we go. So while we're waiting for everything to cool down, I'm going to quickly put together a stack of base core amplifiers into a cooling tower here. So I'll see you in just a bit. Okay, I think that's enough thermal overhead for now. We put in 6 towers with a couple of spaces left on the top of our final 2 here. So let's take a look at what recipes we have left to unlock in the Mega Press. Let's see, we've got batteries and we've got pumps. Now we should be good for pumps now because we already have turbines and impellers set up. We just finished up with valves, so we can put together a pump factory. Let's take a look at Rupture Planner and see how many of these we're going to need. Rupture Planner says 2 mega presses making pumps, so our factories are getting smaller. And then we also saw batteries in there. Batteries, I believe, was 4 if I remember correctly. Batteries is 3, so we need 2 and 3 in order to round off all of the mega press recipes that we can currently make, because there are actually a couple of higher tier mega press recipes that we can see here at the bottom of the recipe station. We have heat shields and ion stabilizers, and both of these things are going to require stuff that we have not seen yet. This is aerogel and uber filament. We do actually have the reinforced frames for this. And then onboard instruments, liquid helium we have, and then explosive charges. Now we need explosive charges for a stabilizer. Who knows? I'm not the scientist making these things, I'm just the engineer manufacturing them. So we're gonna set up 2 more factories here, 2 smaller factories, 1 for pumps and 1 for batteries. So let's get back over here. Actually, we're gonna go back to the recipe station because I have to unlock these before we can make those factories. So let's start with, I guess, batteries. We're gonna need 200 electronics, 300 inductors, and 1500 sulfuric acid. We can bring in the electronics and the inductors via cargo receivers, but I'm not gonna wait for 1500 sulfuric acid to come in. So we'll get these started, and then I'll just go and collect some sulfuric acid by hand. Okay, let's see here. Here are 200 electronics, 300 inductors, and 1000 data points for batteries, so batteries are now unlocked. And for pumps, we should have the remaining sulfuric acid here, and I do actually have a little bit left over. Is there anything else in here that needs sulfuric acid? Compounder, maybe? Here, we'll stick the rest of this into Substance FHS 135493. So, let me go get the rest of the ingredients here for pumps. 100 valves, 300 impellers, and 200 turbines. Okay, this should be it. We have 100 valves, 200 turbines, 300 impellers, and 1500 data points, and pumps are unlocked. So let's go get these set up. And I actually already have our receivers in place because I was using these to pull in our ingredients to unlock our recipes here. So we already have these set to valve TX1. This is valve RX1. This is turbine RX1 connected to turbine TX1. This is impeller RX1 connected to impeller TX1. And then this one is SACD4 pump RX connected to SACD4 pump. So these are all 4 ingredients that we're going to need in order to manufacture pumps. All we have to do is put some mega presses down and connect up our input rails. Now, we had said we're going to need 2 mega presses for pumps, which should be extremely simple. We're going to rotate these, line them up. These will actually come forward 1 because our receivers are offset by 1 in order to squeeze in the buffers. So we're going to push this over 1 tile. Actually, we're going to set this right here. Line them up with the rest of our mega presses here. There's 1, 2. We'll set up, well, let's check our input ratios. Let's see if we can combine any more rails here. So we have 4 independent ingredients for pumps. This is a 10-second construction time, so we should be able to squeeze all of this onto a single rail here, especially considering we only have 2 mega presses this time. So we'll just do a single rail modulator, or a single set of rail modulators. Right, let's go closer. We'll go right here. And right here. We'll flip this around and scoop these up in this direction. Like so. Connect our storage depots to our modulators. And then connect our modulators to our modulators. Feed these through. And there we go. That should be everything that we need to set up for pump manufacturing. Number 2. Now, obviously, this is going to be extremely light output, so we'll just scoop these up and send these to the right. Or if we're looking from the back, it'll be the left. So we'll do rail support, followed by a rail modulator. Modulate these together. Now we know we're going to need for our upstairs level, we're going to need pillars in these locations. And then again in 1, 2, 3, lock our Z. We're going to have 1, 2, 3, 4 will be the mega press upstairs, and then a pillar right here. So it'll look like that. I think we're going to have 3 of them upstairs, so it'll be this footprint, but down here on the bottom, we're going to add a storage depot. We want to put this right here. I suppose we could. We'd have to make sure that we wrap our incoming feed around this pillar. So we'll have to do something like have a rail support here. And then bring this around the back side of this pillar. And then into here. And then we can bring our multi-rail for our dispatcher over here. And have our dispatchers here. I don't know how many we're going to need just yet. But we'll set this storage depot to collect our pumps. Here they come. And we'll check our rupture planner to see how many dispatchers we're going to need. It looks like just 1. Pumps are only going to pressurized tanks, so that's extra simple. We don't even need a multi-rail. We just need a simple rail. Which will match, I think it will end up being right here once we put down our cargo dispatcher. We'll bring this out here. Send this to the left into our dispatcher. There we go. And we'll call this frames please pump. We'll call this pump TX1. And that's it. That's our whole pump factory. So let's slap. Okay, stuff is still coming in. Let's just make sure nothing's backing up. I don't think it will. This is a very simple factory. Yeah, we're fully stocked. So let's slap a second deck on here, and that's going to be our battery factory. Pillar supports. We'll put 2 pillars on each of our existing supports. 1, 2. 1, 2. 1, 2. And then we're going to need to squeeze in some supported platforms here. I want to say we put these in the bottom right-hand corner of each of our receivers. Like this. And then we're going to need 1 more on the end here. Bring all these up by 2. Now, if you happen to catch in the background here that our receiver is still in its original location, I did actually try to move this up with the last rupture, but even when these are burned out, it still won't let me place this here. It still says hazardous area or something like that. Can't place while active, so I don't know if that's a bug. I can place supported platforms over this, but for whatever reason, it won't let me place the receiver over it, so we'll just leave that there, I guess. Let's put some platforms on top of these. And we might need 1 more pillar in this back corner here. Let's just check and see if this is going to be enough. It is, okay. So we actually didn't need that pillar in our last set. But that's fine. It's not hurting anything by being there. So here are our 3 mega presses for making batteries. And I believe batteries is only a 3 ingredient recipe. Let's double check our recipe here. For batteries, yep, inductors, electronics, and sulfuric acid. So let's set up, actually, let's check our ratios over here. So this is a 4-second manufacture. So that means there's going to be 15 cycles per minute. We have a total of 4 input items times 15. That's what, 15, 30, 60. So each one of these is going to be 60 items per minute between everything. So 60, 120, 180. We should be able to squeeze these all onto a single rail. So we just need 3 cargo receivers here. This is going to require some additional platforms. Let's leave that one's probably not going to be needed, but we'll get to that in a minute. We only have 3 ingredients for this recipe. We'll lock our Z. 1, 2, and 3. Grab our storage depot. 1, 2, and 3. Yep, okay, so we'll lose this pillar here. We'll connect our receivers to our depots. We'll set up some rail modulators to collect. I was going to put down a rail support, but then I saw that this one doesn't have a rail support, so we'll just modulate and then output into our mega presses. Hey, when I click, that means I want you to place it. There you go. Rail up. Send it to the right. Hey! What are you guys doing over here? Just a moment. Okay, back to business. Where were we? Right, rails. Okay, modulate to the right. Modulator to modulator, and then modulate out into our machines. Like so. Checking for bad guys. Alright, let's set our recipes up top. Put the gun away. I know you're a soldier, but the threat is gone. Okay, so we have one is set here. We need battery and battery. We're going to need electronics available. We'll take electronics TX1, electronics RX1, electronics. Here we go. We'll take inductors. This one's called Induct 4 Bat RX. And then this one should be sulfuric acid. Do we have one? We should have one dedicated to batteries. Yeah, SACD 4 Bat RX. Peepopog climbing tree hard 4 house. And we'll set our depots, ductors, electronics, and here we go. Did I mess up sulfuric acid? No, I see it flowing back there. There we go. Okay, and because our input numbers, our input quantity is so low, our relatively faster manufacturing time compared to the 10-second times we've been dealing with so far is more than enough for our very small quantity of items to come in here. So this should be everything that we need for battery manufacture. So we'll collect these on the far end. We're making one every 4 seconds. That's 15 per machine. That is way, way smaller than a V3 rail. That's what, 45, 15, 30, 45. So we'll modulate these in this direction. There we go. Now we'll drop in a... Well, this is going to be a little interesting because we put a dispatcher here. So what I may do is move this dispatcher further down, because I need to put a storage depot here, and we don't have enough under space, I guess, for lack of a better term. We don't have enough space underneath here to place this, so let's move this down some more. We're not really restricted on that as much as we are restricted on this, because this needs to go between our mega presses and our dispatcher. I guess let's do another set of platforms here, and we know we need to go up 1, 2, 3 instead of at level. So we'll start this right here. I don't think we need a set of back pillars. I think we just need these. So these are, what, 4 wide? These are 4 wide. So we'll put supported platforms here, and then 1, 2, and then here. And the same thing here. Well, we only need 1 for downstairs. Actually, hang on, this is way too close. We have to put a dispatcher in between these. So it's going to be here, 1, 2, 3, 4, and then here. And then our downstairs dispatcher will go here, up, 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 right to here. We'll move this to here. Like so. And then we'll put a couple of pillars down. 1, 2. 1, 2. Platform, platform, dispatcher. Like so. I did not actually check how many of these we need, so let's check that before we continue. Here we go. So mega presses for batteries are going to 2 locations. Let's just follow this through. We have accumulators and we have generators. So 2 dispatchers for batteries. Put this back down and go back to the game. Easy enough. We'll grab dispatchers. Let's move down here a bit. Dispatchers. Get some frames, please. This is not going to be enough support. So we'll throw down some more pillars. Lock our Z. 1, 2, 3, 4. Pillar. And then 1, 2, 3, 4. Pillar. Going right up to the edge. Platform, platform. Dispatcher. Lock our Z. We just have to rotate and place. Perfect. Now we do need all 3. No, we need 2, right? Yeah, generators and accumulators. Oopsie. I was thinking, I was in the mental state of 2 more, not 2 total. Lose you. Okay, so we'll need 2 outputs from our cargo, or storage depot. Auto-saving. We'll place it here and here. I don't see a reason to put 1 here and 1 here. We'll just run these a little bit further, so we'll go to here. We'll go to here. Break this off. Send this through. Out you go. Okay. Blah. And it would probably help if we put some input into this, huh? Rail into this end. Batteries in. Batteries out. We'll call this Bat TX1. You are Bat TX2. Beautiful. And then we need to set this one back up again. You are Pump. Pump TX1. And I guess we're just going to have 100 extra pumps for something. We'll stick it into the recipe station, I suppose. So there we go. That is for what we have access to material-wise right now. There are a couple more Mega Press recipes, but they are a higher tier item, even though they're on a lower tier manufacturing building. But this is everything that we're going to be making in Mega Presses here. So this is our Mega Press factory. Let's actually, let me do this in no UI mode. We're going to go look at our factory that we made here. We managed to come in under our thermal budget. These are a lot less thermally intensive than our compounders over yonder. So yeah, much simpler, very uniform, I guess, because we only really have two kinds of buildings here. We have mega presses, well, three, I suppose. We have mega presses, we have dispatchers, and we have receivers for the entire factory. Where can I get? I need to be more centrally located for a good flyby. There we go. That's a bit better view. So there we go. This is like, what, 1, 2, 3, 4, 5, 6 different mega press factories, all crammed into 3 neat little rows here. Not too bad. But I think that's all we're going to do in today's episode. You know what? I think we probably have time for one more segment here. Let's do an adventure, because we still have some update 1 blueprints to unlock. So let's feed this guy. I'm going to grab some bullets, and I guess let's just wander. Let's see, can we see any bases? I don't see any here. There's got to be something new to visit on this side of the map here, on the northern side of the stuff that got unlocked for update 1. So let me grab some bullets, and we'll just go run until we find an abandoned base and see if we can loot some blueprints out of it. So I'll be right back. Okay, we're healed up, we're ammoed up. I did actually unlock in between episodes. I unlocked these energy boost capsules, which are like 4 times as strong as a regular serpent root. So this will do quadruple natural energy regeneration for 30 minutes. So I'm gonna pop one of these. I'm gonna go for a little hike. There are a ton of these skylisks out here. I find it's actually easier and get more of these guys if you use the mining gun. And you just kind of drag it through them. Generally, you can only get like 1 shot off on these guys with a gun before they all scatter. But with the mining gun, it's however many you can drag your mining laser through. Hi, friends. Oh, here's some blue on the horizon. Let's go check this out. This is actually right past one of our helium extraction bases right here. I think over there, yeah, there's our like electronics manufacturing and our original chemical base. Oh, bad guys already. Oh my god, look at all the serpent root.
Acquired. I need to survive.
We gotta grab them and run. Alright, we got a couple of buildings up here. I guess we're just gonna, with all this stamina we just unlocked, we're going to see if we can just run through it. If we can get some frames. Good grief. Any blue? No, there's tons of blue color. I'm looking for blue containers. Here we go. I recognize that shape. I forget what it's called. That was one of the things we needed in last episode. We'll get the heck out of here. Later. You know, that was so quick. I think we'll probably just keep going. We want a little more action than that. Yeah, these update 1 areas are definitely a lot more geologically diverse and a lot more complex than the base game areas, which is probably why the update 1 areas are a bit rougher to run through, like performance-wise, just because there's a lot more geometry loading in. And I think that's primarily what causes a lot of the choking as you get deeper into the game. Because I did actually, at the end of the last episode, and again before I started recording this episode, I cut the settings, the quality settings, pretty far back. Like, we're running on basically medium settings right now. I still have the render distance set to the default, but everything else I pulled back. The ground clutter I pulled back. The textures I pulled back. All of the, like, fancy post-processing and lighting effects are all back down to medium quality. I didn't want to completely potato it, but yeah, it's still Still some, not as bad, but still pretty unbearable visual stutter. We're heading towards the radiation belt over here, so I think we'll split to the left. Because there's a lot more to the left than I thought. I thought we were skirting the edge of the radiation zone on our north side here, but there's actually still more to explore in this direction. More bugs. Uh-oh.
I recommend finding a safe place.
That's probably not good. We're way out here. Oh! There was something in... Whoa! Hang on. This is a terrible time to have found this, but look at all this. Alright. Let me fight my way out of the corner here. We're gonna bunk up for the Ruptura, and then we'll check this out. Alright, the sun is back out. I didn't want to go in here during Ashfall to kind of cheese through the whole encounter here, so I guess let's head down where we saw these buildings inside this valley before. We're gonna have some resistance, which we're gonna bypass in our usual way. Excuse me, fellas. I'm not here for you. B2L1T1. We have T2, so we have a lot of buildings right here. I guess let's start here in this big cluster here. Not sure if I've seen that symbol before. Uh-oh, this is gonna be a key card dungeon again. Uh-oh. Oh, we can get in here. Liu Mining Company, who is that? I would love to read this. There you go. Quickly read it. Pause the video and read it if you want to see it. I'm a little busy right now. Oh, hi guys. Hey, you can't come up here. Oh, no, this is exactly like, ow. This is exactly like that other base. We need 3 security cars, okay? Noted. Here, have a voice log.
Yesterday's excavation ended in a small underground explosion. Soon after, Anna saw with her own eyes the ground.
Firearms supposed to be. We'll take bullets.
One of the lower modules.
No, Yellowstone standard access card. Okay, so here's our access card.
According to Dr. Crestwood, this was caused by the
So he was crushed to death by residential module AI.
Cracks in the rocks. Basically, the water turns to ice and pushes the rocks apart. And when it returns to liquid form, the rocks fall and crumble. The pockets made in this way accumulate a lot of unstable hydrogen sulfide. An equipment malfunction.
This is completely trashed.
Resulting in the underground explosion. Dr. Preston thinks there is no cause for concern, but I will continue to monitor the situation. It also won't hurt to ask for upgraded plans.
Oh, we got a building down here. We'll come back to that in a second.
Just listen to an audiocom recording of someone who was here before you.
Uh-huh.
Each recording could contain useful data. So
Fight.
Mr. David has asked that you retrieve as many of them as possible.
Audio logs. Got it. Take some healing. Dead body. We'll take some, oh, here's keycard number 1. What is hitting me? Like I'm inside a building. Okay, so this is gonna work a lot like, man, the name of the other one is escaping me at the moment, but yeah, it's essentially gonna be 3 key cards that we have to collect with the main key card. Here we go. I'll scroll through these real quick. I don't have time to stop and read, but if you want to, you can pause and read them. Out of my way. That's not a building. Well, it is a building, but it's not one we can go into. Okay, so we had one here. There's another one down on the ground to the right. Here's an audio log.
Hey, Dan, did you hear that? Something's exploded again. The ground's shaking.
Everything's fine. Get back to work.
We shouldn't be excavating this close to the living quarters. This entire canyon's unstable. I can feel it vibrating.
Stop.
How did they blow themselves up from sulfur?
Okito, can you hear me?
Hello? There we go. Oh, oh, how did you get in here? Knock it off. We have another tablet. Mining sulfur on Arcadia. Any good? Increases aim speed? Not really. They're coming through the walls! Alright, let's run. We're looking for some more buildings. We have sulfur miners. We didn't check this one down here. This is, yeah, that's where we came down previously. Close the door behind us. Here's card number 2. Take some bullets. First results of terrain analysis. The terrain under the base is full of air pockets, in other words, underground holes. They are most likely created by the regular and sudden expansion of underground water following Ruptura's waves. The hydrogen sulfide released during mining is not only toxic when inhaled, it is also flammable. Sparks produced by the extractors can cause small underground explosions that affect the stability of the terrain. The holes are so packed with hydrogen sulfide that it is replenished almost instantly, even after its sudden oxidation and disintegration during a fire wave. As such, the terrain always remains toxic, but that is not our biggest concern. Aside from the threat to the stability of our entire infrastructure, these small explosions can trigger safeguards in our most critical rooms. I understand that we can't stop mining, but I would suggest replacing, if possible, the extractor with a better model, or better yet, relocating the entire base. The accumulation of the gas inside the terrain can also cause too much of the gas to be released into the lower parts of the canyon. It is highly toxic, and our masks don't meet the necessary safety standards. After speaking with Mark, I know that we don't have enough biofilament to not be concerned by the deaths of the crew. I will soon send a detailed report. Problems with the door. I think this was on another terminal. To answer the frequent questions, due to the instability of the terrain, tremors can trigger a lockdown on the laboratory door. Your standard access cards are not able to lift the lockdown. In order to unlock the door to the lab and or the technical room, you need to go to someone higher up. Aside from my own card, the cards of Dr. Miyamoto, Dr. Presswood, and Dr. Harris have the necessary access level. If for some reason I will not be able to unlock the door, you need to go to one of these 3 people and ask them to unlock the door. The logistics department knows their current assignment. You can write to them or go directly to the building D1 above my office. Please don't bother them unless it's a real emergency when getting into the laboratory is absolutely crucial. Please also remember that it can be opened from the inside even if the alarm is on. We're working on fixing this, but we don't know how long it will take. On behalf of the entire Liu Mining Company, I apologize for any inconvenience. Is that a trick we can use? The door can be opened from the inside even if the alarm is on? Is there a way to get inside without needing the key cards? There is some crazy stuff going on outside. Let's check up top. We already got a key card in here, right? That was the first thing we grabbed when we got in. Yeah. Ow, 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 how? How am I getting hit? Let's get out of here. Excuse me. Alright, where else can we check? I guess let's look down this canyon. There's another one that branches off in this direction. Which is the same way the last one worked. The base was split into like 3, like a triangle pattern. There was 1 key card in each of the 3 paths. Oh, here we go. We've got a hollowed out building here. Ooh. Take some healing. Excuse me. Don't touch. Take some data points. We've just got some loot here. A tablet you can read if you would like.
Reloading.
Let's go over here. There's a lock on this door. Oh, but it's open. Never mind. War bonds. There's a key card in here. Dr. Harris's security clearance card. What? You don't even need a security card on this door. You can just walk in here and grab this. Dr. Harris, private research journal. You have to read that on your own. Sounds like we're about to get attacked. Okay, let's go. We have all the cards that we need. That's not fair. The frame rate cut out. It didn't accept my second jump input. Hi guys. You seem like you're having a little problem pathing around here. How do we get back up top? We'll go here. Ah, here we go. Stairs up. And it was this building here. Up the ladder, right? Yeah, here we go. Okay. 3 cards.
Yesterday's excavation.
We listened to that? We listened to that already. Alright, let me in. I can't close the door. Unfortunate. Get out of here. What are we looking for in here? Storage box. Item printer. Oh, we can go down. Audio comm.
Hey, Anastasia. Is something wrong?
Nothing. The doors are still getting stuck.
Yes, I know.
We'll take this.
Once I check the plan,
Here we go. Okay, for all this, we get plastic dust and anti-radiation covers.
what are you talking about?
Nice. Hey,
Not without
knock it off.
Not so. I'm sorry, Scott.
for what?
Grab that.
Anastasia, what are you doing?
Oh my god.
We're on a planet where everything can kill you. To die at the hands of your colleagues.
I missed the context of that.
Depressing?
Alright, let's see. Problems with the door. Good morning. In accordance with guidelines, we're sending you the coordinates of planned local excavation areas. Details can be found in the attachment. Oh, that's base coordinates. This always gets me because you'd think the one that's highlighted is the one you're reading, but that's just, it's showing you that this is a new mail. Problems with the door. To answer that frequent question, due to the instability of the terrain, we read this one already. Okay. So, not much going on at the end of the adventure here, but we got what we came for, so let's pop this door. Let's get the heck out of here. Okay, I'm back to base, back to safety. I didn't check what that blueprint was that we got out of that first base. Let me take a look real quick. That was nano syringe. That's right. Okay, well, there we go. So we wound up with 2 extra blueprints because I think we already had plastic dust. So we got nano syringe and we got anti-radiation covers. So all new stuff from update 1 that we'll be building in an upcoming episode here. I'm not quite sure how long it'll take us to get there, but we're through mega presses for the most part now. We have a couple of higher level ones to polish off, but I think in the next one we're going to get to working on our extra compounder recipes, and then we'll be able to get to assemblers and beyond. So yeah, pretty good progress today. We got a little rail science done, we got a little building done, we got a little adventuring done, a nice well-rounded episode. So hopefully you enjoyed it. If you made it this far, then thank you for watching. If you're enjoying this playthrough of StarRupture, hit a like and subscribe. If you want to check out StarRupture for yourself, head over to Steam and pick it up. And if you want to let me know what you think of the game so far, then hit the comments down below. But whatever you do, I'll see you right here again in the next one. So, until then, bye-bye.